Welcome to the first AI exercise of Chapter 4. In the lecture, you learn the selection of an artificial lift system is not a simple lookup problem. Engineers evaluate reservoir conditions, well geometry, fluid properties, production performance, and operational constraints before recommending gas lift, an ESP, a sucker rod pump, or a hydraulic pump. There is no universal equation because every well behaves differently. In this notebook, we convert that engineering knowledge into a machine learning workflow. The first section imports the Python libraries required for data processing, machine learning, and visualization. The next section creates a dataset, since there is no publicly available datasets containing thousands of labeled artificial lift decisions. We generate more than 2,000 synthetic wells covering realistic ranges of productivity index, gas-oil ratio, viscosity, reservoir drive mechanism, and environmental sensitivity. Each well is then assigned the most suitable artificial lift method using the engineering rules discussed in this chapter. To make the dataset more realistic, we also introduce a small amount of uncertainty because, or let's say noise, because experienced engineers do not always agree when a well sits close to the boundary between two lift methods. Once the dataset is prepared, we divided it into training and validation, sets. The random forest algorithm is trained using only the training wells, while the validation wells remain completely hidden. This allows us to evaluate how the model predicts decisions for wells it has never encountered before. After training, we examine the confusion matrix, and classification report to assess model performance. More importantly, we analyzed feature importance. Rather than simply asking whether the model is accurate, we ask why it made a decision. Productivity index, depth and gas-oil ratio emerge as the dominant variables. The model is reinforcing the engineering principle that govern artificial lift selection. Finally, you'll use the interactive prediction tool. Enter the properties of your own well, compare the model recommendation with your own engineering judgment, and examine the confidence score for each lift method. Remember, the objective of this exercise is not to replace engineering expertise. It is to demonstrate how artificial intelligence can organize engineering knowledge, recognize patterns in complex datasets, and provide transparent decision support. The engineer remains responsible for the final decision. Thank you very much. If you want to have this notebook, please comment and provide your email, and I will send this to you accordingly. See you in the next